Good morning, students. In today's lecture, I'll solve additional mathematics paper 1 of Cambridge International Examination 4037 and variation 12, May-June 2018. The first question states that it is given that y equal to 1 plus tan 3x. State the period of y. Now, the regular period of sine x and cos x is 360 degree. Now, tan x, most of the time students make mistake. Let me write down the period of sine graph and cos graph, regular, parental or regular sine and cos graph equal to 360 degree or 2 pi radiant. Okay, but tan graph, it's actually 180 degree or pi radiant. Most of the time student mistaken its period to be 360 degree or 2 pi radiant. So over here, period t equal to, see, I have this 180, so I can write down 180 divided by b. Okay, that's the formula. Okay, and 180 divided by b is 3. That means 60 degree. Okay, period of this one is 60 degree. Now, question number 2, 2 is saying this domain is given 0 degree to 180 degree. Over here, nothing is said. So if you, by mistaken, you put pi by 3, that also gonna be okay. All right, either 60 degree or pi by 3 radian. Now, let's say on the axis below, sketch the graph y equal to 1 plus tan 3x for x to be greater than or equal to 0 but less than or equal to 180 degree. Now, regular interval of this one is 90 degree. Okay, 0 to 90, 90 to 180, 180 to 270, 270 to 360. But whenever I have b3, then 90 divided by 3 for this particular graph function of tan function, its regular interval would be 30 degree. Okay, so what I'm gonna do, I'm just gonna see, these are the regular interval right over here. So that's regular interval, and that's another regular interval for parental graph y equal to tan x. But when it's a number of cycle is 3, the regular interval is 90 divided by 3 is 30 degree. So I'm just going to draw this few lines over here, and then I'm gonna draw this. Okay, now this one, see that one over here, that one is baseline. There is no value given, so I'm just gonna put this one right over here. Okay, and we're gonna put y equal to 1. Okay, now what happened is sketch. You don't need to draw the table, make the table. You can just do it if you want. But if you want to do the table, go ahead, do that. No problem with that. But I'm gonna do the just regular way. Okay. But before I do that, I always love to show you the other way to do this. If this is 90 degree, okay, this is 180 degree, this is 270 degree, and this is 300 degree. Okay, 360 degree. So this is 90, this is 180, this is 270, this is 360. The reason I have done this, I wanted to show you how this y equal to tan x graph looks in between 0 degree to 360 degree. Okay, this is just a recap. Okay, so if I from here I draw that or sketch that, you will understand what I'm doing. The tan graph is going like this, and then it's gonna go something like that. And over here, the period over here is not 360 degree but 180 degree. The reason is, look at this, in between 360 degree I have 2 complete cycle. If you bring this one over here, add that, it's gonna be actually another complete of this one. So there are 2. So the regular interval of this one is, our period is this one, 360 divided by 2 or 180 degree. Now over here I have 3 cycles. So within 360 degree I supposed to have in 360 degree for parental one, I have 2 cycles, and when I have 3, I supposed to have 3 cycles, okay, in this particular one. But since 180 degree, within 180 degree, I should have 3 cycles, okay. So from 90 degree, my regular interval for this graph would be 30 degree. That's what I said, okay. So this is 30. So this graph is gonna be from here. So two things I have to change, from 90 to 30. And this one, look at this. This baseline was over here, y equal to 0. On x-axis, y equal to 0. But over here, this is going to be, baseline is going to be y equal to 1. So two things, the regular interval changes from 90 to 30, and then baseline changes from 0 to 1. Okay, so that's that. And then next one is going to be like this. Okay, and then this one going to be like this, and then last one is going to be this. Now if you bring this one over here, so 1 complete 1 2 3 cycles, so that's what is this one. Okay, so number 1 is done. I hope you understand that. If you have any question, I have one video how to draw the tan graph. I hope you can go ahead and check that. Okay, now find the value of k for which the line y equal to 1 minus 2kx, this is a line, a straight line, does not meet the curve y equal to 9x squared minus 3k plus 1x plus 5. Now, what this actually means, let's say this graph is something like this, okay, and this is a straight line, they do not meet, and it has a negative gradient, so it should be something like that, and they won't meet. How are we gonna figure it out? Simultaneously, what are we gonna do? We're gonna put the value of y in this equation, and then we're gonna go with the discriminant, because that determines the nature of the roots of the quadratic function. Okay, so y, this one, y equal to 9x squared minus 3k plus 1x plus 5. And what did I say? I'm going to replace this y by that. So it's going to be 1 minus 2kx equal to 9x squared minus 3k plus 1x plus 5. If I bring everything to this side, it's going to be 9x squared minus 3k plus 1x. Bring this one over here, so that's going to be plus 2kx. I had 5 initially, and this one comes over here, minus 1, and everything comes over here, everything goes over here, so it's like that. Now from this two terms, I can see that there is x, so these are the like terms. So what I'm going to do, I'm going to take x common. So when I take x common, it's going to be 3k plus 1, and since I have taken minus common, so that's going to be minus. See, this thing becomes positive, and this sign is going to be negative. And if I take x common, it's going to be 2k, close bracket, then x, and this is going to be plus 4 equal to 0. Now what can I do? I can simplify that. 9x squared minus, when I take the bracket of 3k minus 2k, that's going to be k plus 1, that x plus 4 equal to 0. Now this is the equation when this graph, this curve and this line intersect, but the root is imaginary, or there is no real roots when they don't meet. And we know that that thing happen when b squared minus 4ac is less than 0. So it says that they do not meet, does not meet. See that? This is the phrase you need to be careful of. So according to the question, they do not meet. What is the value of a over here? The value of a is the coefficient of the highest power of x, and that in this case is 9. And b is the coefficient of x, and that's going to be minus k plus 1. And then coefficient of x to the power 0, or constant term, or the term independent of x, is c, that's 4. So what happened? B squared, so minus k plus 1, then whole square, minus 4a is going to be 9, and c is going to be 4, that less than that. I can see that 3 is a perfect square, and 4 times 4, that can be written as 4 square. Okay, so when I take this bracket off, I'm gonna have here minus 1, let me just write down that minus 1 whole square, and k plus 1 whole square. And this can be written as, I hope you can see that, 4 times 3 then whole square. See, 4 square and 9 can be written as 3 square. So I'm taking 2 common and multiply that. And this is going to be positive. Okay, so that's going to be k plus 1 whole square minus this is going to be 12 square less than 0. Now this one is in the form of a square minus b square. A square minus b square, I hope you know that a square minus b square is nothing but a plus b, a minus b. Okay, so that's what I'm going to do. K plus 1 plus 12, k plus 1 minus 12. Okay, that's 0. So it's going to be k plus 13. And over here, k minus 11 is less than 0. Now, what this actually means, that see that k over here, whenever we had this one was positive, so this thing is going to be minus 13 somewhere, and that's going to be 11. The graph should be looking something like that. And over here minus 13, and over here 11. Now this is x-axis, and x-axis y equal to 0. This equation y equal to 0. Let me write down a little darker ink, y equal to 0. And this is my y-axis. So this is the origin, x's value and y's value is 0. So up we go, y is going to be greater than 0, and below we go, y is less than 0. I hope you can see that. Now this thing says function of x or y is, this whole thing is y is less than 0. So we are talking about this part, and this part is happen when x equal to x is greater than minus 13. Then see, this curve is below the x-axis. That means y is less than 0 or negative. And then it's below the x-axis happen all the way to x equal to 11. Then when it's more than 11, y becomes greater than 0. So since the y is less than 0, then we can say that k is over here greater than minus 13 but less than 11. In this case, okay, this line doesn't intersect with this curve. Okay, so that's my final answer. Okay, all right, now question number 3. It says that variables y and x and y are such that when e to the power y is plotted against x square, I'll just show you this, what they mean. E to the power y, that's vertical line, and x square is over here. Since it's not in our regular y plotted against x, so this is a linear law. Or we can say this one is a straight line graph. Okay, so it's like that. E to the power y is plotted against x square, a straight line graph passing through the points. So these are the points 5, 3 and 3, 1 is obtained. Find y in terms of x. This one very important, y in terms of x. So we know that linear law goes capital Y equal to mx plus c. Now this one, m is the gradient and c is the capital Y intercept. In this case, c is e to the power y intercept. Now to get that, first I need to, this is always true for your linear law of this kind of questions. Find out m, and that is gradient, okay, and then find out c, and that's capital Y intercept. Okay, intercept, and rest of them are going to be very easy in this type of math. So we know gradient. The formula of gradient is difference in y-axis, y2 minus y1 divided by x2 minus x1. If I take this one y2, so it's going to be 1 minus 3. I took this y2, so this is going to be my x2, 3 minus 5. So that's going to be minus 2 divided by minus 2 equal to 1. That's my gradient of this particular thing. Okay, and then let's write down y equal to mx plus c, and take any coordinates of the point. I'll go with a smaller one. I could do this one, but this is smaller. Okay, in the place of capital Y, I'm gonna put 1, and gradient I got 1, and x is 3 plus c. So c equal to 1, this is plus 3, comes over here. So it's gonna be 1 minus 3 equal to minus 2. So I have the value of c is this, and gradient is 1. Now, what was my equation? It's y equal to linear law equation mx plus c. Now, y, we do know that e to the power y. So we replace that e to the power y, and m we got 1, and capital X is x squared over here. So times x squared, and plus c was minus 2. So rewrite that e to the power y equal to x squared minus 2. Okay, c equal to minus 2. Okay, now we are not done yet. It says y in terms of x. So what I'm going to do, I'm going to take ln on both sides. So ln e to the power y equal to ln x squared minus 2. Whenever it's like that, I can bring y over here. Now ln e equal to ln x squared minus 2, and ln e, we do know that it's equal to 1. So this is equal to 1. Therefore y equal to ln x squared minus 2. So that's my final answer. Y in terms of x. Y in terms of x. Okay. Now let's do question number 4. A particle P moves so that its displacement x meter from a fixed point O at time t second is given by this thing. Find the value of t when the displacement of P is 3 meter. So let me write down that x equal to ln 5t plus 3, and then this displacement is 3. So according to the question, displacement is 3 and we need to find out t. Ln 5t plus 3. So this can be written as ln, that base e, so 5t plus 3 equal to e to the power 3. Okay, so what is t? Now from here I'm coming to this side, so it's 5t equal to e to the power 3 minus 3. So t equal to 1 by 5 e to the power 3 minus 3. You can keep the answer like that, or what can you do, because it didn't say anything. Okay, we have to keep the answer at exact value or the decimal. It didn't say that, but let me do this in decimal. That's 3 minus 3 divided by 5. So just for the timing, I'm going to write down is 3 significant figures is 3.42 second. Okay, so that's the t's value when displacement is 3. All right, find the velocity of p when t equal to 0. Now velocity is ds dt. Now I need to differentiate this. When I differentiate that ln this, so 1 by 5t plus 3, and then chain differentiation, I have to differentiate inside that bracket. So 5t plus 3, if I differentiate that, I'm going to end up with 5. Okay, but it says when t equal to 0. So v when t equal to 0 equals to 5, and this thing comes 0. See that 5 times, let me write down that 5 times 0 plus 3. So the answer is 5 by 3. You can keep it as it is, or you can write down 1 whole 2 by 3, or if you want to put it in the decimal, it's going to be 1.67. 1.67. Again, nothing is written, so we can write down that, and don't forget to give the unit. It's gonna be meter per second. Okay, so either one will do. Explain why after passing through O the velocity of P is never negative. Okay, question number 3. Explain why after passing through O the velocity of P is never negative. So velocity equal to it's given what was that, 5t plus 3 after passing through O. So if O is over here and we are going this way, we can see that this thing is 1 2 3 4, and t is getting bigger and bigger, or getting bigger than 0. So when it's bigger than 0, look at this, it's increasing. It's the value is 1 2 3 4. So v is never ever is negative. It's never equals to negative. Okay, so since t is greater than 0, v equal to 5t over 5t plus 3 is never negative. So you can write down the velocity velocity of p is never negative. Okay, that explanation should be okay. Now just do a little further if we want to make this negative. Okay, so therefore 5t plus 3 has to be less than 0. Then t has to be less than minus 3 by 5, and we can clearly see that after passing t, you will never be less than negative 3 over 5. So velocity will never be negative. Okay, I hope you understand that. Find the acceleration of p when t equal to 0. So acceleration is dv dt, and we had that. So it's gonna be you can do it in the quotient rule, or you can do the product rule. Which one I want to do? Let's do with the product rule. 5t plus 3 minus 1. So this is 5, and that's gonna be minus 1, 5t plus 3 minus 1 minus 2, and if you differentiate this whole thing again, it's gonna be 5. So on the top it's gonna be minus 5 times 5 is 25, and below here is gonna be 5t plus 3 whole square. So that's my acceleration, but that's not it. They are asking find acceleration when t equal to 0. See that t equal to 0. So that's gonna be minus 25, and 5 times 0 is 0, plus 3 square is 9. So that's meter per second square. You can keep the answer like that, or you can do a lot of things. You can write down 2 whole 7 by 9 meter per second square, or decimal 2.78 meter per second square, and it has negative sign, so this is deceleration. Okay, so that's done. Let's do question number 5.1. The first three terms in the expansion of this can be written as so and so. Find the value of each of the constant. All right, very good. Let's do that. It's 3 minus 1 by 9x to the power 5. That can be written as what do I want to do? I don't want to do really quick. 5, I'm going to use the formula. Okay, I can do it really quick. See that 5c0 equal to 1, and then this thing gonna be 1, and this is gonna be 3 to the power 5, but I don't want to do that. I'm gonna go step by step. 5c0, 3 to the power 5 minus 0, I'm putting the formula, and over a minus 1 by 9x to the power 0. That's the first term. Second term would be 5c1, then 3 to the power 5 minus 1, and then minus 1 by 9x to the power 1, and there are three terms. Another one, 5c2, 3 to the power 5 minus 2, and minus 1 to the 1 over 9x to the power 2. Okay, now these things, first three terms is given a plus b over x plus c over x square, and this thing 5c0 equal to 1. Trust me on that. Then again, don't trust me. Okay, we're gonna find it out. See that 1, and 3 to the power 5 is gonna be 243, and this anything to the power 0 is 1. So 1 times this times that equal to 243. Now when the power is 1, this negative gonna be negative, so this is gonna be negative. Now 5c1, that's gonna be 5, so that's 5, and then 3 to the power 4. See, 3 to the power 5 minus 1, that means 4, times 3 to the power 4. We got 405 divided by 9. So divided by 9, I end up getting 45, and below here I have x. Okay, now this is a squared third term. This is the third term, and with the negative value I have a square. So when take the bracket off, it's gonna be positive. So positive, positive, positive. 5c2, that's gonna give me 10. Now, and this is positive 10, and 3 to the power 5 minus 2, that's 3. 3 to the power 3 is 27. So that's that. Divided by 9 squared is 81. So I got 10 root 3, and x is in the denominator, so I can write down x square. So that's that. Now I can compare this. Okay, I can compare this a with this. See that? It's a constant term or independent of x. Therefore, a equal to 243 and b, see, denominator is x, denominator is x, so b is going to be minus 45. Okay, so b is this one and c is going to be over here. Below here is x square, so I'm not interested in x square. C is going to be 10 by 3. Okay, so that's my answer. This is 3, by the way. Oops, it doesn't look like 3. This is, anyways, 10 by 3. Okay, so that's my answer. Okay, now it says use your value of a, b, and c to find the term independent of x in the expansion this. Now what I'm gonna do, see that first few terms I got for this one, 243 minus 45x plus 10 by 3x square. I don't need to do any more. I'll explain in a second why. I'll just keep that. And over here, see that 2 plus 9x whole square, that means in the form of a plus b whole square. And we know that it's going to be a square plus 2ab plus b square. And 2 square, a square, 2 square is 4 plus 2 times 2 times 9. Okay, so 2 2s are 4, 4 9s are 36x. And over here, b square means 9x whole square. That's 81x square. Now watch this. Independent of x. That means either in that term x to the power 0 or we can say no x. Okay, that's not division, just two options. Okay, now over here, if I multiply this with this, I can see that there is no x. Okay, so required term, okay, independent of x, independent of x term, that independent of x, that's 243 times 4. Okay, so that's the first one. Then plus second one, look at this and this, if I multiply this x and this cross out, so I won't have any x. So minus 45 times 36, that's another. So this and that, and this two, when I multiply this x square in the denominator and x square in the numerator cross out, so that's going to be 10 by 3 times 81. So I can cross this one, 27, so that's going to be 243 times 4, that's going to be 972. Then this is minus 45 times 36, minus 1620. And over here, 27 times 10 is 270. So 270 plus 972 minus the answer I got, negative 378. That the answer. Okay, so I hope you understand that. From question number 6, I'll do it in the next video. Okay, take care. See you later. Bye.